Okay, this is Mr. Peterson, and we're continuing with the 5-4 notes. This is page 5. All right, this number 20, example 20, has, let's see, what have we got here? We got a 12, an 11, and a 5. And there is no greatest common factor that goes into those. So I'm going to make a note here. There's no GCF on that one. So what we're going to do here is just skip that step and go straight to the star method. So I'm going to set it up and put my little star snowflake over here. And my leading coefficient is going to be that 12. You put that on the sides. And you multiply these two numbers here, the 12 and the negative 5. And that gives negative 60. So we need to find two numbers that multiply to give negative 60 and add to give 11. Well, the factors of 60 are 1 times 60, or 2 times 30. 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7, 8, and 9 don't go into 60. So we've got the list here. And you're looking for numbers that multiply to give 60. That's the ones that are listed. And that add to give 11. Well, we could get 11 with these if we use a negative and a positive, and that's what we need up here anyways. So we're going to say 4 and 15. And the way to make the 11 happen is to put the negative on the 4. Double check. Do these two numbers multiply to give 60, negative 60? They do. And do the same two numbers add to give 11? We're good. Okay, the next thing you want to do is to simplify these. This is going to be 3 over negative 1. Treat it as a fraction. And this is divided by 3 here. You get 4 over 5. Now we simply turn it sideways. The 3 over negative 1, you're going to write it as 3n minus 1. And the other one, 4n plus 5. So you could check it. These give 12n squared. Those two give negative 5. So these work. Now let's see if we can get that middle term to work. Get a minus 4n and a plus 15n. Those add up to 11n. Okay, the next one has a GCF, but that's all it has. And you'll see that in a minute here. So pull out the GCF. The greatest common factor here is 5 and x. Let's see, multiply that by 3x squared to get the first one here, plus 2x to get the second one, and then to get this one, you have to multiply the 5x by negative 2. Okay, so we're going to try to do the star. It's going to fall on its face here in a minute. All right, so set up a star here. Leading number is 3. That goes on the wings. 3 times negative 2 is negative 6. And put that up there. We have to multiply to give negative 6 and add to give the number below it, the 2 there. So 1 times 6, 2 times 3. That's the only way to get 6. Well, these numbers might add up to 7, or even if you change one of the signs, you could get a 5. And then simply by reversing that, you could even get negative 7 or negative 5, but you can't get 2. We're trying to get 2 when you add them. Okay, these add up to 5, or negative 5 if you made them both negative. If you had one negative and one positive, you could get a 1 out of those numbers, or a negative 1, but you can't get 2. So there is no possibility for these two slots here, and consequently this doesn't work, and our answer, our factored answer, was what we did earlier, right there. Okay, this last example I have in this section, there's no GCF, and the star fails. So let's see what we got here. Is there a number that divides into 3, 4, and 2? And the answer is no, other than 1, which we ignore all the time. Is there an M all the way down? Almost, but there's no M at the back. So there's no GCF. The next thing you want to try to do is see if you can get this star to work. And we're going to run into the same buzzsaw we had before. Your 3 is your leading coefficient. Put that on the wings. 3 times 2 is 6. Put that at the top. You're trying to multiply to get that and add to give the number that's below it, the middle number there, 4. And let's see what we got here. 1 times 6 and 2 times 3. Those are the ways to get numbers to multiply to give 6. But we can't get 4 out of these. This could be 7 or 5 or -5 or -7. This could be 5 or 1 or the negative versions. But neither one of them can you get 4 adding them. So fails both times. No GCF and fails the other way. So it does not factor is what this had. This one does not factor. And when it doesn't factor any way possible, you write prime. This is a prime expression. A prime expression is precisely one that does not factor. Okay, we have another style of factoring, and this one is a pattern factoring. So if you catch on to how this works, it's actually pretty easy to do. It's called perfect square trinomials, and so I'm going to just spend a little bit of time showing what a perfect square is. And the last example here, example C, is a perfect square trinomial. So 81 is a perfect square. It could either be 9 times 9, or maybe -9 times -9. 121n squared, that's 11n times itself. So 11n times 11n, or 11n squared. And the last one, and I'm going to show you, my goal here is to show you in a minute how I do this here, but it's going to be 5x minus 6 times 5x minus 6. And you'll be quick at this. It's not hard to do. Now, we will pick up on page 6 with what to look for in order to do these perfect square trinomials. This is actually the perfect square trinomial over here. And when you factor it, since these factors match, you can write it as a perfect square. So I'll show you how to recognize these first on page 6 of the notes, and then I'll show you how to factor them.